In a previous video, we looked at how to manage multiple pipes by creating a simple program that was passing around three processes, a number that was incremented by each. Now, in that lesson, which you can check up top, by the way, I didn't look at creating this program in such a way that you can make as many processes as you wanted. So it was only limited to something like 3, and it was kind of hard coded. It was kind of difficult to actually make even more than that. And since then I got a lot of requests to actually make that program. So here we are. So the idea is that you have the main process. Let's say it's this white box, and what we have it do is pass in a number. Let's say here that it passes a number x, suppose it has the value, let's say 5, right, to another process, right? We have here another process, and this process, what it does is it passes it down to another process, but not before incrementing it. So it passes, instead of 5, it passes 6. And then you have another process that does that, and then you have as many processes as you want, right? And then at some point you're gonna have to have a result which is gonna be however many processes you have plus 5, let's say, something like that. How do we create such a program? Using fork and of course pipes. So let's think about first how many pipes we need, right? This is our program, and let's say we don't have an infinite number of them. Let's say we actually do have these, only these 4 processes. Well, with 4 processes you actually need 4 pipes, but remember that this guy here is actually the main process. I'm going to denote it here with main. That means that we only need to create 3 processes. So let's say here 3 processes, but 4 pipes, right? 1, 2, 3, and 4. All right, so if we create n processes, we're gonna have to create n plus 1 pipes and open it accordingly. So let's go ahead and start doing this. First things first, let's create the pipes. I just want to have all the pipes in one place. I'm gonna say here int, let's say pipes of however many we want to create. Now I'm gonna define here a hashtag define process num. Let's say that's the number of processes, and that's gonna be, as a start, let's simply start with 3. So we're gonna create 3 processes, but we're gonna have the diagram that we said we're gonna have there. So since we have 3 processes, then we're gonna have 4 pipes. Okay, that's fine, and we're gonna actually open all these pipes and say for I equals 0, I less than process num plus 1, I plus plus, and then if pipe, to open the pipe, we're gonna pass in here, and we actually have to have here an array of 2, so it's gonna be an array of process num plus 1 elements, and each element is an array of 2. So here we're gonna have pipe of pipes of I, of course, and this is gonna be an array of 2 that we have a pipe in. And this is, if this returns -1, let's say printf error with creating pipe \n, that should be fine. Now that we have the pipes created, let's create the actual processes. Now this is a bit more tricky, and this is something that I didn't really discuss in the course for processes so far, but it's actually pretty easy how to create n number of processes and have them execute a specific portion of your code. You would naively start with a for loop and say, okay, well, if we have an I less than process num, and this is, for example, here we have 3, and if you just call in fork, of course you're gonna get, well, whatever process num processes you're gonna have. So we're gonna have here 3 processes. But that's not quite how it works, because the first fork is going to create a second process, right? So now you have 2 processes executing the same for loop. Then the next iteration of that for loop gets executed on both processes. So instead of getting only 3, we get 4 processes, right? And then the third loop, we get 8 processes. and so on and so forth. So you get a lot more processes than what you would expect. So because of that, we cannot really do this. We actually have to check a couple things. And I'm going to also store the process IDs in an array. So I'm going to have here, let's say up top, int PIDs, let's say PIDs, and that's process number of process IDs, and it's going to be PIDs of I equals our fork. So it's going to fork, and if, let's say, if PIDs of I is -1, then something bad happens. I'm going to print here error with creating process \n. All right, and I think we should also return, yeah, let's return out of the programs in both cases, because I don't care what happens afterwards. Something went wrong. If something goes wrong with forking, of course. Now, if something doesn't go wrong, that's great. So what I want is to check if we are in the process that we just created. To do that, we just check this value. If it's 0, we are in the child process. All right, that's amazing. Now, what do we actually do here? Well, here we can execute whatever we want the child process to do. But the key difference between the previous for loop is that you actually return out of this if statement. So if you say return 0 here, then the for loop is not going to be executed by any of the child processes. We're going to have, for example, let's say the main process executes fork. So it creates a second process, but the second process enters this return 0 block, right? So the second process stops executing. Now the main process is not going to enter here, of course, because it's not a child process, and it's going to continue executing the for loop. The second time it comes around, it does the same thing, and it does the same thing, and again, and again. And it just creates the processes, but they get terminated before being able to loop around the loop. Another thing you can do, if you want the process is to continue executing here, but not have them really exponentially grow in numbers, right, like we saw there, then you could break out of the for loop. Right? So you could break out of the for loop so that every child process does not execute fork again. Right? So once we break out of it, we just go end up here. So in a fork, we are in a child process, we do evaluate this to true, we break out the for loop so we don't execute it further. But then you're going to have to be careful here what executes what. So in our case, we're just going to return 0 out of that, and that's perfectly fine. And one key thing is waiting for these processes to finish execution. Naively, you might want to wait in here, say wait of null inside the for loop, but that's not quite right, because that means that, well, you're going to create the process and you're going to also wait for it to finish execution before you have created other processes. So that means that everything will be sequential. So you might as well just have it just one process that does everything sequentially. So this is not right. The right way to do it is to do the same thing, but in a different while loop. So I'm going to copy here the while loop that we have here and simply call wait null here at the end of our program. Okay, so that way we wait for all the child processes to finish execution properly. Now here comes the more difficult part. Which pipes do we use? How do we use the pipes, and, well, which one do we close? Which one do we not close, and so on? That really looks kind of complex. Well, to do this, you actually have to sort of come up with a standard for which process uses which pipe end, of course. We can denote the pipes as being something like this, right? And every dot is really an end of a pipe, and every really pair, every column is a pipe on its own, right? So let's say that the top half are all the read ends and the bottom half are the write ends, and we should note down here the index. This is the whole array, so we have the pipe at index 0, the pipe at index 1, the pipe at index 2, and the pipe at index 3. We have only 4 pipes, right? Now, let's start assigning some pipe ends to each process. Now, one standard we can come up with is have each process read from the pipe that has the same index as our own. You know, as since our code actually here has a for loop, in here we do have access to our I variable. And in every process, that I variable is different, right? For the first process is 0, for the second process is 1, and so on and so forth. That's quite handy because we can use that in here. We can say the first process gets the first pipe's read end, right? So let's say, let me actually pick up a different color so that it's actually different than what we have here. So basically we have to read from this end into this process, right? This is going to be our read end for, let's say this is the first process, and this process is going to write, well, it's not going to write to this pipe because, well, then that's not right, because it's just going to write to where this guy is reading. No, it has to write to a different process. So therefore we're going to have it write to the pipe with its index plus 1. So if the process has index 0, then it's going to write to the pipe at index 1. Okay, that's fine. And then the next process, let's say this is the process with the index 1, is going to read from the pipe at index 1, of course. But it's going to write at the pipe of index 2. And then the second one is going to do this, and of course write on this index. And out here you're going to actually have two leftovers. You're going to have this one and this one. Now these are the ends that you're going to read and write from main. So the main function is actually going to, let me get my brush here, it's going to write first to the first pipe here, and it's going to read from the last one, because nobody else reads from the last one and nobody else writes to the first one. And that's how our program is going to work. Now, the most important thing is that each process actually closes all the other pipes that we have created. Because note here, we have created however many pipes we have in here. This is process num plus 1. So in our case, we have created 4 pipes. But every single pipe has been copied for every single child process. So all in all, we have something like 4 times 4 processes number of pipe file descriptors. So we have 16 file descriptors open, right? So we're going to have to close most of them. Therefore, in here, we're going to have to create another loop, let's say int j, and for j equals 0 till, of course, process num, and actually we do have to say process num plus 1 and j plus plus, and we're going to have to close everything that is, well, let's say I close the read end of every pipe, right? I say pipes of j of 0, right? The 0 denotes the read, and that's not quite right because I want to read from somewhere. This one place has to be read from. But I did say that if the index of the pipe is the same as our index of our process, then we want to read from that pipe. Therefore, we should say if I is different than j, so if we are on a different index, we want to close that pipe. But if it's on the same index, we want to keep it because we're going to have to read from it later. Now, for the right end, so we have here pipes of j of 1 this time. Well, this is more or less the same condition, except, as I said, it's the index of the process plus 1. So if I plus 1 is different than j, we want to keep that pipe open, so we're not going to close it. So only if it's different, then of course we want to close it. And by this point we have all the pipes that we are not going to use, all the pipe file descriptors closed. Okay, that is perfect. Now we can actually read from this. So you can say int, let's say x, and if you're going to call a read, and I'm going to read from where? Well, we want to read from pipes of, we know that the pipe that we want to read from has the same index as our process index, which is I, so we're going to say pipes of I, and we want to read from the read end of that pipe. Perfect. Next, we want to read into X, of course, and we want to read size of int bytes into it. And if it does return -1, so if this is equal to -1, then let's say printf error at reading \n, and I guess we can return if that somehow happens. It shouldn't happen in our case. Nice. Now we read the number, let's say we increment it, and now we can write to a different pipe. So you can say write of pipes of what? Well, as I said, it's not the same pipe, so if I write to pipes of I of 1, that's the same pipe as we read from. And if each process just writes to the same pipe that it read from, nothing is going to happen, right? So we're going to have to write to the next one over, which is I+1. Okay, we want to write X and size of X, or size of int in this case. I'm going to check if this is -1. If this is -1, then again, it's really error at writing. I'll return 4 there. And that's almost everything that we have to do in the child processes. Remember, everything here is the child process. And in here, what we have to do lastly is close the other file descriptors, the other pipes that we have used, but we're done using them. So we have to close pipes of I of 0, and we're going to have to close pipes of I+1 of 1. And then return 0, of course. Now one last thing we have to do, and that is in the main process, because we didn't take into consideration the main process here. So here, since all the child processes do return out, here only the main process runs. So here what we want to do is write a number. So let's say here int y equals, I don't know, let's give it the number 5, and let's write to some pipe. And we said that in our diagram here, we said that main should write to the first pipe. So that's simple enough. We just say pipes of 0 of 1. And of course we want to pass in y and size of int. And again, if that's -1, let's copy this out so that I don't have to write it again. Oh, that looks ugly. There we go. And next up, we should also read the results. I'm going to say read of pipes of what? Well, in the diagram, I said that it's the last one. So the last pipe is, well, process num as an index. Remember, we have process 1 plus 1 pipes. So this actually is valid. And of course, of 0, we want to read from the read end. And then we pass in here, let's read into y, why not? And say size of int, it shouldn't be -1, but if it is, we're gonna print out error at reading, and there we go. Let's align that properly. And let's printf the result. Let's say the final result is %d\n. In here we just write in y, and let's say wrote main process sent %dy. That's the first statement. And before I launch this, I'm gonna actually add some printf statements, because otherwise it's very difficult to understand what's going on. So here I'm gonna actually paste in this, and let's have here a simple identifier, and each child process is going to say got %d, and that %d is going to be our x that we have just read, and this %d is actually going to be our I, that is our process index. Okay, and then we can say here, after we write, we can say sent x. So here we should see x as being the original value, and this one should print out that value plus 1. Alright, now we should try executing this. And let's see what did we get. As a result, we did get main process sent 5, so that's fine. And then the first process got 5, sent 6. The second process got 6, sent 7, got 7, sent 8. And then the final result is indeed 8. So that's amazing. We have 3 processes, one more than what we had before, but this time we can actually increment the number of processes to something much bigger. We can say, let's say 10 processes. So if we try to run this, well, we should get a proper result. And indeed we do get that. And 5 is being sent all throughout all the processes. Here we can know that the processes are different because of the I being printed here is different. And the final result is also correct because it is incremented 10 times by 10 different processes. So that works properly. One thing that I think I forgot is to close these pipes that we have also used. So that's actually important that we close them once we're done using them. It's just something that forgot. Although to note, it's not 100% necessary to close these file descriptors, as the modern operating systems do actually catch up on these, and they do at some point actually clean them up. But it's a good thing to do this because you might want your code to run on some ancient version of a Linux distribution or who knows what, and it will be great if it clears its resources properly. And of course we want to also close all the other pipes that the main process doesn't actually make use of. So we're going to have to copy this for loop here and use it like so, make it a bit more clear what's going on. But we do have to change the indices here because we don't have I, we actually have setup numbers. So the condition is going to be J is different than process num. So basically if it's the last pipe, then we don't want to close that because that's where we read from, right? Process num of 0. And similarly for the right ends, we don't want to close the first pipe's right end because that's where we start writing. Okay, and that's gonna be it for this video. So what do we learn from this video? Well, we did learn how to create a number of processes in a for loop without creating a fork bomb, basically, by simply having here a condition on whether or not it's a child process, and then inside this block returning 0 or even breaking out of the for loop if you want to execute the child processes further down the line. All right, we also learned how to create and close the pipes accordingly. So you first create all the pipes, that's the easiest way here, and then you close them, you close the ones that you don't actually use, and then of course close the ones that you use after you use them. Similarly for the main process. And we did learn that we do have to call weight of null in a separate for loop, similarly to how we do with threads, because with threads you have pthread create and then you have pthread join, that they both have to be in separate for loops. Now the whole code kind of looks complex, but it's pretty short, and if you think about it, it's fairly logical. You may even be able to simplify it even further. Here I have, for example, this for loop that kind of repeats. Maybe you can do something about that, create a function or something. That'd be great. You could also have the user type in however many processes he wants to execute, and that would be a nice homework. I think you should actually try doing that. It's interesting, and it has to do with dynamically allocated memory. Or you can experiment with sending out different entities through the chain of processes. Instead of numbers, you can send in floating points or even some custom-made structures. I hope you enjoyed this lesson, and I hope you got something out of it. If you do have any questions, leave them down comments below or on our Discord server. Again, the source code for all this will be found on our website, link in the description below. Take care. Bye.